that we know about branches, nodes, and loops, we can talk about how there are series connections, parallel connections, and also connections that are neither. So for series connections, this is when two branches are connected exclusively at one node. So simple resistor, resistor, and then put some source here or something. These two resistors are in series, and that is because they are connected by a single node. The other sides are not connected to each other. And, this is the very, very important word here, exclusively, there is nothing else connected at that node. So this node that connects them, it only connects those two things and nothing else. On the other hand, parallel, this is when two branches have two connections through two nodes. So an example here would be, here we have our source, here we have our resistor, here we have another resistor, and you see these two resistors are connected at the bottom node, and they're also connected at the top node. So there's two connections, and they are through two different nodes here, therefore they're in parallel. Now, you may have noticed something else here. In the first picture, this source has a single connection that's exclusive to the bottom resistor, so that source is in series with the bottom resistor. Similarly, that source has a single connection that's exclusive to the right resistor, so therefore that source and the right resistor are in series. And so in this first circuit, everything is in series. Similarly, on the second circuit, that source is also connected to everything here by two nodes, and so that means all of those things are in parallel, not just the resistors. Now the reason why we care about series and parallel resistors are that whenever you have something that's in series here, so whenever anything's in series, if you have some current traveling along the circuit here, so you got whatever 5 amps or some other number going along here, it never has a choice as to where to go. It always has to keep going forward, and there's only one way forward until it gets back to the starting point. And so the thing is, whenever you have elements in series, they are going to have the same current. Always have the same current. On the other hand, if you're trying to do that in the parallel circuit, as current's coming here, it has two choices. It can keep going straight or it can go down. So you are not going to have the same current on a parallel circuit. However, in engineering, as you'll see as we go throughout things, there's a lot of this duality between problems. And so in one of them, if they're in series, they always have the same current. The dual nature here is that when they're in parallel, they're always going to have the same voltage. So in this case, the voltage across the voltage source is going to be the same as the voltage across the first resistor, which is the same as the voltage across the second resistor. So whether things are in series or parallel, that's going to be a very useful piece of information when trying to solve a circuit. I do want to point out that sometimes you have things that are in neither. So let's do something like this here. If I look at this resistor and this resistor, they are connected by a single node, not two, so they're definitely not parallel. However, that single node is not exclusively connecting those two resistors, so that means those two resistors are not in series or not in parallel, which means they are not going to have the same current and they're not going to have the same voltage. So at this point in time with that bottom circuit, you really can't say much more. However, we are going to learn how to handle circuits like that.